The first spacecraft equipped to take a sample from an asteroid is preparing to lift off from Florida Space Coast in September on a mission vital to unwrapping some of the secrets of mysterious near-Earth objects. Near-Earth objects emit no light of their own, so researchers get few opportunities to study them as they cross through sunlight that reflects their features to instruments on the ground. That's where OSIRIS-REx comes in. Weighing 4,650 pounds when fully fueled, the spacecraft will rocket away from Earth on a path toward an asteroid called Bennu.
OSIRIS-REx is an awesome acronym that captures the primary scientific objectives of our program. The O stands for Origins. We're seeking answers to clues to the origin of our planet and to the origin of life. SI is Spectral Interpretation. Spectroscopy is a technique we use with telescopes and spacecraft instruments to determine the composition of an object's surface. RI is Resource Identification. We're going to a near-Earth asteroid. We're going to map it with our cameras and our other science instruments to identify the minerals and chemicals that may be on its surface. The S is for Security. Because it's a near-Earth asteroid, there is a small likelihood that it may impact the Earth sometime in the 22nd century. And finally, we're a regolith explorer. Regolith is a term for the gravel and dust on the surface of the asteroid, and our prime objective is to explore that material by bringing it back to Earth.
A United Launch Alliance Atlas V has been stacked at Space Launch Complex 41 to start the spacecraft on its way. Standing some 19 stories tall, the rocket with the spacecraft protected inside a payload fairing will fly on a carefully planned course into space.
NASA and LSP have a great history of launching our science missions on Atlas V. It began in 2006, and we have launched 12 critical science missions on this workhorse launch vehicle. OSIRIS-REx will be our 13th mission.
The small spacecraft will go into orbit around the floating rock and carefully survey its surface, relaying the data back to Earth. Scientists will select the best place for the spacecraft to reach out its mechanical arm and tap on the surface to trap dust and material in a tiny canister. Researchers will like to find material from the original formation of the solar system.
The primary objective of OSIRIS-REx is to bring back 16 grams of pristine, carbon-rich material from the surface of Bennu. We're really interested in the organic chemistry of these asteroids and the roles these kinds of objects may have played in the origin of life.
OSIRIS-REx will retract its arm and place the canister in a capsule where it will be protected during the ride back to Earth. With its mission done, the spacecraft will fly by our home planet in 2023 and release the capsule holding the asteroid sample. The capsule, protected by a heat shield and equipped with a parachute, is to fall through the atmosphere and be retrieved in the American Southwest.
The OSIRIS-REx mission uses a sample return capsule to bring the material back to the surface of the Earth. We'll land at the Utah Test and Training Range, just to the southwest of Salt Lake City.
From there, researchers will carefully evaluate what's expected to be a couple of ounces of asteroid that could answer some of our most fundamental questions about Earth, the solar system, and the universe. Part of the analysis will include a close look at what was found that may have been picked up on Earth during processing instead of from the asteroid. Planners thought of that, though, and have a step in place they say will prevent confusion.
In this case, we're doing something a little bit different. It's never been done before, called contamination knowledge. We're able to put plates out there where we just have them in the same environment as the spacecraft, and then we'll save them. So in a few years, when the sample comes back, we will have these pristine in storage. When we start analyzing the samples we got back, we can go back and look and see, did we have that? Did we see it on the ground, or did we bring that back from the asteroid?
Teams have been working on the OSIRIS-REx mission for more than 10 years to plan a sample return flight, develop the spacecraft, and get to this point close to launch.
I was involved with the original spacecraft selection process when OSIRIS-REx won that selection, and then we bought the rocket for it in 2013, and I've been integrating that rocket ever since.
The OSIRIS-REx team has worked really hard to make this mission a success, and everybody is very excited and enthusiastic. I can't wait to send this spacecraft on its journey to Bennu and back and begin the next phase of operations.